Bob. Thank you so much for the kind introduction. And I will talk about today and our, the sustainable materials research at Ford Motor Company. And this is kind of, the overview. And if you want to more discussion, and please let me know. And we are doing lots of cool research on the sustainable materials, either bio-based materials, or we call it renewable materials, or recycled materials. And I will introduce my supervisor as well, Debbie Milevsky, and everyone knows is a bio lady or green lady, and she's very famous. And if you type her name in Google or YouTube, and you can find her very easily. All right, so let's start with the agenda and what I'm going to talk today. So I will start with the first, what is the drivers for us, and what are the challenges on sustainable materials? And I know it's, so far we talk about more in recycled materials, and I will touch a little bit the renewable material as well. And also, our success on renewable materials, we have 8 different renewable materials at Ford Motor vehicles right now, and we are working almost every day to increase our sustainable materials in our vehicles. And our current research and development, sustainable composites and foams as well, because we are also using polyurethane foams extensively in our vehicles. And also, I will talk about the ocean plastic. And I see that, this morning, and there was a good discussion about the ocean plastic, and we call it an emergency because it's getting a really big deal for us, and also the final and the best part, the acknowledgements parts. So, sustainable materials, and we are always asking this question, why we should use sustainable materials ourselves, and also our supplier as well. We are working very closely with Tier 1s, Tier 2s, even Tier 4s as well. So increase use of renewable feedstocks and agricultural products. And we have lots of waste materials staying in the landfill, especially agricultural products, and we would like to use more in our vehicles. And increase use of recycle and waste byproducts. In every industry, they have waste products. And some of them, it's, that their waste materials is treasure for us, to be honest. And reduce depends on the the petroleum-based materials. It's most of the plastic is oil-based, and we try to reduce our dependency. And improved our material life cycle. And when we do the life cycle assessment, and when you put the recycled materials or lightweight materials, which is bio-based materials, always provided, and you get favorable life cycle approach. And also, it seems people, especially consumers, they really like the green materials. And of course, there are good things about sustainable materials. There are also challenges about the sustainable materials. And I divided 2 different sections: is renewable materials and also recycled materials. In the renewable section, automotive environments. And when we design our materials, we need to make sure it's gonna stand 10 to 15 years. So, and also materials need to be thermal and mechanically stable between -40 to 125 Celsius. It's a harsh environment. Appearance requirements. And customers, they don't want to see the fibers in the past, but right now they want to see the fibers in the inside of the vehicle. And seems Class A definition is changing, but it's one of the problems with the renewable fibers. And compatibility issues. And a little bit chemistry here, because renewable material is hydrophobic and they like water, and most of the polymer is hydrophobic and they don't like the water, and always create compatibility issues. And moisture, because of the hydroxyl groups on the surface, the materials absorb more moisture. And processability and porosity issues, and also degradations, because renewable materials can degrade in early temperatures, and if you try to mix nylons or PET type of materials, and you can see the degradation issues. In terms of the recycled material section, we try to use the more recycled materials. Sometimes we have this kind of problems, a lack of market for the recycles, and a lack of infrastructure, how we are going to separate the recycled materials. And economics, sometimes we find the recycled materials getting expensive than virgin plastics. That's cause problems. And that's a very important one is the mindset and knowledge gap. Even our own engineers or our suppliers, when we talk about let's use recycled materials, their first reaction, oh, do you think recycled material is going to make it? And we find that after that, even recycled materials meet all the requirements, even sometimes provided better properties for us. So let's talk about our success a little bit. So in 2008, and after 7 years of research and experience, we first put the soybean oil-based seat bags and seat cushions. And we put it in Ford Mustang vehicles, and everybody told us, are you guys crazy? You are putting soybean oil-based foam Mustang vehicles. People love it, media love it, and here we are today. All the vehicles made in North America, they use soybean oil-based seat backs, seat cushions, and headrests, and right now we are trying to put it for headliner applications. And you can see, the trend with the year, and also we calculated, we have over 31,000 soybean used our seed actually. And also when we look at it, the life cycle assessments and see how much we save, and 30 million pounds of saved annually actually. So this is another one, and we are working with the farmers very closely, and this is with the Canadian government, and we are working with Ontario farmers. They have more than 25,000 members. So they provided funding to us, and they said, can we use wheat straw materials in the vehicles? The first reaction, why not? And we work, I think it's 18 months development and research. Right now we are using Ford Flex. If you have Ford Flex and look at third row seat and in the storage bin, and you will find wheat straw materials. This is not only bio-based materials, and we are saving 8% weight reduction, because original materials are talc film materials, and we are saving from the the weight, and also good life cycle assessment, and also cycle time saving. So that means molder, they can produce more material in a day or in a production cycle, and also energy saving using this kind of materials. So, and also canop fibers. So we are trying to replace, our door bolster materials is originally either polypropylene or ABS type of materials. And we replace with the canop fibers, and we save 50% from the weight. And just to give you an idea, 10% weight reduction, 6 to 7% fuel economy. So that's great for us actually. And this is still in the productions. And this is another one, is the cellulose fibers. So I didn't mention about my background. I got my PhD from forest resources, and I focus on more materials from the forest-based materials. And this is the kind of research, and I done back in the days, try to use cellulose material in the plastics. We are working with the very, very good suppliers on that, and they said that they are making pulp and paper products. And as you know, we cannot compete Brazil, Russia, China to make it pulp materials. And they are really suffering, and we are trying to make it more functional material using cellulose-based material. And we talk with the teams, and we tell them we are going to change to fiberglass materials or glass fiber. The first reaction, are you guys crazy? You never meet the fiberglass requirement with a cellulose-based material. And we formulated, and we changed the extrusion process, and we made it materials. And we replaced 20% short glass film materials, and 6% weight saving, 22% cycle time saving, and 50% energy saving. And we are trying to migrate it for other applications. Right now we are thinking, this is make it electrical bracelets, console substrate, even IP parts using this material. Bob already mentioned, I am from Turkey, and when I came to this country, even I didn't know that we are growing rice. And I went to Arkansas and I see that people growing lots of rice material over there. And after the rice is pretty much, it's staying in the landfill, and that is no value for this material. And we took this material and we formulated with polypropylene materials, and we made it electrical bracelets. And this is for F-150 series. Just thinking about, and sometimes people say, oh, this is very small parts, but we are making million F-150s. So if you multiply your weight with a million, and you come up with big numbers. And we are trying to migrate it for this one for other application as well. And coming next, so we have a different strategy, working in the morning and working in the evening. And working in the morning, my supervisor, she loves coffee, and she consumes like 5 or 6 cups. And she asked me, Alper, is there any way we can use the coffee type of materials in our productions? And we look at the coffee, the waste materials, and we work with one of the big coffee supplier, and they said that they have coffee chaff. We think about the coffee bean, outside of the bean, and they call it coffee chaff. They are using for either animal feeding or staying in the landfill. And also the burlap bags, because you need to move, you need to move or carry coffee bean place to place. But after a certain cycle, it's the waste material. So this is our morning strategy, and evening, and you people once again enjoy. Hopefully they will serve some tequila tonight. So we are working with one of the tequila supplier and Jose Cuervo, and they are using agave fibers to make a tequila, but during the processing, and they have a waste material, and I will talk about in detail as well. So when we choose the biofiller selection, and we need to be very careful because we need to make sure the materials is producing in a sustainable way. And we choose the Wisconsin fibers, and this is it's growing in Canada. And why we choose this material is non-invasive grass, and it's utilized and land unsuitable for the forage crops. And also we need to make sure we are supporting farmers and also availability of these materials. And the other one is why we choose the coffee chaff and burlap bags, and because of the global availability. And also, once you combine coffee chaff and burlap bags, and you will get very good mechanical properties. And the problem is, if you try to use fiber itself in extrusion process, and you will create odor and VOC, which is not acceptable for body interior applications. We need to be smart, and we need to find way to eliminate odor and VOC. So that's why we develop process. They call it carbonization process or torrefication process. We are taking materials up to certain temperature, and we are eliminating the low molecular weight materials like hemicellulose, extractives, and after that you get either the pure carbon type of materials or cellulose material in your formulation. And what we made it from the coffee chaff, and with our supplier together, and we are making the headlamp housing. It's a really big part, and we have 2 in each vehicle. And this is gonna be low-cost material, and think about like that. We have 40% talc fill material for headlamp housing, and we are replacing with this one with 30% coffee chaff and burlap bags. And look at the results, and we are meeting and exceeding our current specifications using these materials. And also, we are getting 17% weight reduction, and higher HDT and better impact resistance, and comparable properties. Like I told you, knowledge and the mindset is really important. And we said, okay, we've done all the properties, but one of the engineers told us, oh, this is bio-based materials. How about fungi or bacteria that can grow on this material? And we did this test as well to just make sure we are meeting every requirements. And but we find that no fungi or bacteria grow on the samples. So target programs, and we are targeting for Lincoln programs and also F-series for this material. That was our morning stories. So this is more our evening stories. And Jose Cuervo and Tequila and Blue Agave fibers. So Jose Cuervo also is a family-owned companies, and they are producing the tequila since 1795. It's an old company like ourselves. And this is the largest tequila maker in the world. And they said, if you go to Russia and Germany, they consume lots of tequila, which is good. And take almost 7 years to grow this material. And during the process, you can see that the circular things is pinaya. And you just extract the materials for the agave fibers, but other materials are leftover materials. And also you can see our chief engineer, and he went to the Mexico, and he wants to see this material in their place, and he loves it. And right now he's the big champion for this project, and we need to make sure it's going to vehicle. So we did some the testing on this material, 8% weight saving. And at Ford, we have the programs farm to car parts. It's a good example from farm to car, and the farmers and people, they love it. And this is the target application for the knee bolster assembly. And this is the low-cost material, and it's beneficial for the Ford Motor Company. And also, we need to make sure we are creating another revenue for the farmers and also companies as well. So, like I told you, we are looking for nature a lot. And if you go to some states like Maine, 95% of the land is covered by forest. If you go to Michigan, 50% of the land is covered by forest. Can we use forest-based material in our applications? So we are looking in deep in the, the tree-based materials. If you look at deep, and you will find nanomaterials, or we call it nanocellulose in the trees. And they are small, but their effect huge, actually. Low density, potential for lightweight materials. And when you look at all the numbers, it's favorable for life cycle assessment because it's really lightweight material versus glass and talc materials. And biodegradable, renewable, and most compared to other, the nanomaterials is non-toxic materials. And also it provided high strength and high modulus. And we are thinking, using this material as a cow and grill application in the vehicle. So this is the, another approach. And I didn't mention about the too much on the recycled materials, but we are using a lot of recycled materials. Like we are using material from carpet industry. And when you look at the carpet manufacturing, you see 4 different layers and 3 major polymers, like the nylon 6, PET, polypropylene, and these are the very common the materials from the carpet industry. And we are already using carpet materials for our underhood applications, and we are looking for other applications as well. So this is the recycled polypropylene, is it from carpet industry, and also we are looking for natural rubber replacement. Believe it or not, and history, and if you look at Ford history, 1927, Henry Ford, and he came together with Thomas Edison and Farley Firestone together to find alternative rubber materials. And they look at more than 1,000 different species, and they look at goldenrod type of materials in deep to produce natural rubber materials. Right now in Arizona, and we are growing Violi type of materials, and we are looking for Violi as an alternative for natural rubber. Or we are looking for Russian dandelion as an alternative for rubber materials. And we are mixing with the graphene. It's a really hot topic right now. And see, can we use the graphene as a reinforcing material in the TPO or rubber formulation. And the target application is convent grills, bumper cover, and wheel lips. And we did some research, and we find that this material is really applicable for this kind of applications. So we call it from zero to hero bio-based polyamides. And I think it's one of the biggest challenge for us to the work on the bio-based plastic materials. When we look at the bio-based plastics, it's really key for us to get the durable materials, because I already mentioned automotive environment is really harsh. So we need to pass like 70 Celsius, 95% relative humidity, and we need to look at mechanical and thermal properties after 4 weeks. We look at PLA, PHP, or other starch-based materials, but it seems it's really hard to pass automotive environment. The only one is so far we are very successful is bio-based nylons. So you can get bio-based nylons from the castor oil, and you can see the green one and also the red one. The red one is the the petro-based one, and the green one is the castor oil-based one. You can find the up to 100% bio-based source. And right now we are using PA11 in our fuel lines, and I think it's 95% of the vehicles produced in North America, they use bio-based PA11 in our fuel line applications. And we are trying to look for other applications like fuel connectors or other fuel system components using bio-based nylon materials. So let's talk about a little bit sustainable foams material. So we were very successful, using soybean oil-based materials. But the problem is the global availability, am I right? If you go to Europe, in Asia, and we always get questions, what about this material edible and non-edible content? Or this material is not available in certain region of the world. And that time we are looking for local source. Like in Asia, we look at palm oil or castor oil as an alternative to soybean oil materials. And even we are looking for upcycling. So we are working with the supplier. We are getting recycled PET from automotive applications. We are using in 14 different places PET materials. And we are getting scrap PET materials, upcycling to polyol, and we are trying to make it either headliner or somebody interior parts using this material. We look at algae as well, and we look at some coffee-based the polyol and other alternative material as well. And also we are thinking some addition of the fibers as well, see what we can do actually. We are adding some cellulose nanomaterials. less than 1%, and we are seeing improvement over 50% in mechanical and thermal properties using this kind of materials. So we did, a couple months ago, the press release about this CO2, and I think it's a really big issue right now, and working on the, the CO2 type of materials. And we have a Paris Agreement. I think it's more than 170 different countries. They, sign, the Paris Agreements, because the world temperature is rising really, rising incredibly. Like 1 to 2 Celsius improvement, increase in the temperature, it can change people's life. So that means we need to work all together and come up with idea. So we are working with the suppliers, and they are capturing CO2 from manufacturing plants, and after that we convert that CO2-based material to monomer and to make it polyol. And we capture, and we are trying to make it right now headliners and or seed formulations. And we did some research, and right now, we are in the second phase, because we are right now working with suppliers and our tier ones to get the real parts for the vehicles. It seems the getting CO2, the polyol from CO2 is provided better mechanical and load-bearing properties. Even we have trucks. In the trucks, we have the mattress, and we are thinking either mattress application or headliner applications using these CO2-based materials. Right now in foam, and we are working with other companies also making hard plastic as well, like a base, the PET type of materials, either make it seat fabrics or headliner fabrics using the recycled CO2. So I really enjoy with this morning discussion, and this is really emergency, for us, to look at the ocean plastic pollutions. And I'm pretty sure you are very familiar with these slides. And it seems if we continue use more plastic material, especially for consumer goods, and we will see in 2050 fish amount and ocean amount is gonna be the same. This is really scary, and that's not good actually. So I look at the numbers, even numbers are getting really crazy, and they said, they're estimated in 2010, this number is even getting probably bigger. They said 4.7 to 12.7 million tons of plastics. And I look at the numbers of how many tons of materials on the surface actually. 250,000 tons on metric tons on the surface. Some people said this is only 1% of the plastics in the ocean. Think about like that 99% of them is on the the oceans and debris and fish, the birds and other mammals, they eat plastic materials. It's not good for our future. So this is kind of take-home message for us. We need to make sure we design the right material for our applications. For automotive applications, it seems there are the huge trend in Europe, end-of-life vehicle directives. 85% of the plastic it should be reused and recyclable, but we don't have this requirement in North America. But since we are a global company and we need to follow the global trend, and we try to make sure we are using more sustainable plastic. So that means the thermoset materials is very good in terms of mechanical and thermal properties, but they are not easy to recycle. So when we make car parts and we try to use more, the thermoplastic materials, make sure recycling is easy. And right now with the research and development proposition at the material design level, and also we try to use circular economy solutions, including making car parts from the recycled ocean plastics. And I think what we should do all together, we need to make sure the plastic is not going to ocean. And if it's in the ocean, we need to work together and capture that CO2, capture that plastic materials and make it, different, the parts for different applications. I already know that, the companies they're making jeans, shoes, or other consumer goods or bottles from the, ocean plastics, but this is not enough. And I think we need to work together and produce more parts from the ocean plastics. And this is our group, and we are really focusing on sustainable materials. And our key is to bring more sustainable and recycled material in the vehicles. And we are, one of our goal also education, and we are always hosting high school interns and college level interns, and we need to make sure we are giving mindset to next generation people use more sustainable materials. And finally, I really want to appreciate it for all of your time and listening my talk. And let's work together and use more sustainable material for every single applications. Thank you.